Hi, good morning, or good afternoon, or good evening, depending on what time you are watching this video. I want to talk to you today about writing in science and how we're going to write a scientific argument that we will be needing to do at the end of each investigation. So what we use, how to write So I know I've said this before, is that we in science, we don't care about what you think, we care about what you know. So we use what is called claim, evidence, reasoning. Well, CER for short. So how most investigations that we're going to be doing is going to be driven by a driving question. So most investigations Our question today is, does the temperature affect movement of molecules? So what we want to know is, does the temperature, maybe the outside temperature, does that affect the inside temperature, internal, external, does that affect the movement of molecules? We're going to watch I'm going to do a demonstration. So we're going to watch the demonstration. So you're going to, at the end of our investigation, you're going to have a claim. And then this still looks a little out of focus to me. So I'm going to try to focus this in again. I'm going to make this a little brighter. Hopefully that will be better for us. So your claim, this is the first thing you're going to write, is the concluding statement that answers the driving question. Sorry to mute there, dogs. So when writing the claim, we have to write it because this is about writing. So when writing the claim, these are some things you want to think about. So when you're writing this, make sure your claim only answers the question. Make sure it doesn't include any reasoning. No reasoning. It should be more than a yes or no statement. So if you think about, does the temperature affect the movement of molecules? You wouldn't just write, yes, it does. So you would write, as the temperature increases, the molecules move faster, or as the temperature decreases, the molecule moves slower. You are just not writing a yes or no statement. It should be one complete sentence. So as the temperature increased, the molecules moved faster, comma, but when the temperature decreased, the molecules moved slower. Or, as the temperature increased, the molecule movement stayed the same. It should be accurate, specific, and it should answer the question. Accurate, specific, should answer the question. It should be more than a yes or no statement, and it should be in complete sentences. You can make yourself a little checklist, like, yep, when you write this, yep, it only answers the question. That's all I have in there. I don't have any evidence, and I don't have any reasoning in it. It's just answering the question. So you could check that off. Yep, I got that. Is it more than a yes or no statement? Yep, I have that. Should it be one complete, is it one complete sentences? Yep, I have that. Is it specific and does it answer the question? Yes, I have that. If you have those things, your checklist is done, check, check, check. Then you move on to evidence. So the next part is, it's just not your claim, but you have to support it with evidence. And this is the data that supports your claim. So I want to talk about two types of data. Two types of data you can have. It doesn't always have to be a quantitative. And quantitative is going to be dealing with numbers or quantity. Numbers are always good, but it can also be what's called qualitative. And this is it's not dealing with numbers. So two types of data is quantitative and qualitative. These are not going to have numbers. These are usually like descriptions. Like how green something is, or if you see a color change happening, that would be qualitative. Quantitative would be like the rate of a reaction, how fast something goes. Quantitative is going to deal with anything that is not numbers. So when you are writing your evidence, it needs to be sufficient enough, and it needs to be relevant. It needs to relate to your claim. So not all data is considered evidence. So what I mean by that is it relevant? So you might be gathering evidence that's not related to your claim, but it's going to be working itself in maybe with scientific reasoning or helping you think about why this happens. So not all the data that you're going to collect is going to be relevant to your claim. So you wouldn't need to include that. And then make sure you have enough evidence to support. Okay. So not all your evidence is going to come from your investigation. You should have other places, other sources to get your evidence. So where can you get enough evidence? Where can you get supporting evidence? Websites. Maybe there's other investigations out there. Class notes. Personal experience. And don't forget your investigation. Maybe there's some computer simulations. You need to have numerous pieces of evidence to support your claim. Okay, it's just not one and done. We need more than that. So let's think about a checklist. What are some things you should have when you are collecting and writing your evidence? So think about, is each piece of evidence relevant and is it related to the claim? Is there enough of it? Do you have more than one piece of evidence? Do not. So make sure that you are not putting any reasoning or explanation as to why this is happening. And make sure you're, oops, can't see what I'm writing. And then make sure it's specific, it's not generalized. Okay, last thing we are going to do is we are going to write about the reasoning. The reasoning could be the hardest part of your argument. Oh. All right, so your reasoning. Your reasoning is the explanation scientific that connects the evidence to the claim. Make sure it's a scientific explanation. Okay. You have to know the science behind it. You know, why do we get the results we get? There's science behind that, right? So it's going to show why the data you chose counts it as evidence. Kind of acts as your conclusion of your experiment. I don't like experiment, I like investigation. And this is a big one. It showcases your detailed understanding of the scientific principles involved it includes so it's going to include correct scientific vocabulary. That correctly ties the evidence to the claim. So it's going to act as your conclusion. It's going to say why you chose the data you chose. Why does it that support your claim? It's going to showcase your understanding of those scientific principles, and it's going to include the correct vocabulary that ties the evidence to the claim. So when you are writing your reasoning, here's a checklist for you. Is there a justification of how each, so remember we have to have more than one piece of evidence. So is there a justification for how each piece of evidence supports the claim? So make sure that you have justification for each piece of evidence. Do not repeat your evidence. I should put just. Do not just repeat your evidence. So don't just put there were no movements of the molecules when the temperature changed. You want to find a link between why the evidence supports the claim. So don't repeat your evidence. Write the link. That would be your scientific principle. Between the evidence and the claim. So that must lead us to making sure you have the scientific principle there. Did you write it? And then don't forget Did you write in complete sentences? So you're going to ask yourself these questions. Is there a justification? Do I write that justification that links those to the evidence to the claim? Do I have enough of it? So for each piece of evidence, do I have that scientific principle there? Making sure that I have that scientific principle. I've wrote that like 3 times. I've written that 3 times, making sure you have the scientific principle. So make sure you know it. That's how I determine, do you understand the principles behind this? You know, why this happened. Investigations are fun. We like to do them, but we need to know the why they happen. All right, that's the nuts and bolts of it. So we're going to do one together. I'm going to set my lab up, and you're going to not even know I do that. Okay, welcome back. I have us all set up. My question is, let me raise this up a little bit so you can see the question. Our driving question is, does the temperature affect the movement of molecules? So why don't you write that down, and I'll show you how I've set all this up. Okay, the first thing we want to do is I have 2 beakers. I have one with ice water. We want to just look at the temperature here. We'll determine what the temperature is. Let's see if I can zoom this in a little bit for you so you can see, but it looks like it's getting pretty low there. And then for another minute. I'm going to say it's about, I'm going to say it's about 4 degrees Celsius. And now let's look at, so that's our ice water. Let's look at this temperature. Rising, we can see that's warmer. Give that a minute. You can say that's about 45. Okay. So I have 1 warm water, I have 1 cold water. Now I have a test tube. Let's go a little further. This is further so I can get it. And I don't know if you can see this, but there's a, you can. There's, I just put some green water in an acrylic tube. There's nothing in my test tube except for air. The water is not moving up, it's not moving down. So that means that the pressure that is coming in from the outside, molecules that are coming in from the outside are equaling that pressure as the molecules that are coming in from the inside. Okay, what I'm going to do is I'm going to first put it in the warm water. Let's watch what happens to my water plug. See, it begins to rise. So now it's risen up. And we're going to put it into cold water and see what happens. Oh, and it decreases. Oh, it's really decreasing. Let's see if we can get that to rise up again. So it rise. Let's see it fall. And I'm going to try to move this back a little bit so you can see it even better. So let's see if you can see this better. This is the warm water. And this is the cold water. Warm water. Cold water. So why is it moving up? There's air molecules in here, and there's air molecules outside. So the amount of pressure that these molecules are putting in right now is equal to the amount of pressure or movement of the molecules inside the tube. So our tube is not moving. Our water plug is not moving. But when I put it in the cold water, what's happening? What's happening to those molecules inside here? Are they moving faster or are they moving slower than what's happening if I put them in the warm water? So that plug moved up and down. Here's another thing we can do. Diffusion is the movement of molecules from an area of high concentration to low concentration. I can use some food coloring. Remember, here's my warm water, here's my cold water. We can see if I put a couple drops there. We can see which one it spreads through faster. So does the temperature affect the movement of these molecules? So we can see in the cold water that the red food dye is staying still close together. And we can look here in the warmer water that those molecules of red food dye are starting to diffuse or move quicker. So again, going back to, does the temperature affect the movement of molecules? Well, there's two pieces of evidence we have. We have the red food dye inside of warm water compared to the rate of diffusion of red food dye in cold water. You see that it's slowly starting to move. And what I'm going to have you do is rewind this or move backwards and maybe time it. And timing will give you even more evidence as to how long the diffusion process occurred. And then we also had the movement of our water plug in cold water as compared to warm water. And again, remember that inside this tube, there are air molecules. And what happened when I heated up the air molecules, they moved faster, 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 compared as when I put it in cold water and those molecules stopped moving. Some things you want to think about is, what is the definition of temperature? What does that mean? What happens when temperature is raised? What happens to those molecules? Why do we say something is hot? Why do we say something is cold? So we're going to research those things, we're going to discuss those things, and we're going to come up with our reasoning. So you should, by this time, have answered the driving question, does the temperature affect the movement of molecules? And that's going to be your claim. We've given you two pieces of evidence: the diffusion of red food dye in warm water compared to the diffusion of red food dye molecules in cold water. And then we also have the movement of our water plug going from hot You can see it moved up to cold. And you can see it moved down. Still moving down. All right, that is it for today. We will continue on in class the next time I see you.